Cool. So I wanted to try to give you as much of a work day as I could. I think it would be really helpful if we just took some time to practice some of this stuff, because I think that's really kind of the piece that we're missing right now is just getting a chance to work on this and see how it goes. But first, questions about anything from yesterday? Because I know you guys did it from a distance. I'll put up ABC, and I know we didn't get to D. We'll do D for sure. But good with like the factoring and crossing stuff out and rationalizing and crossing stuff out and one-sided limits and all that stuff. Okay. What I'm going to do for sure is along the way today on pages 26, 27, and 28, I'm going to do a bunch of them as we go. I'll probably put up almost all of them kind of throughout, at least 60% of them throughout class, but I want you to do your own thing too as you go. So the thing that I want you to realize is that once we get to like E, and we try plugging in -2, you're going to be dividing by 0, and so we just can't do that. Right? We can't try direct substitution if we're going to get an undefined answer. F, G, H, all dividing by 0. I, divide by 0. J, divide by 0. K, divide by 0. L, M, all of those are dividing by 0. And so we want to make sure that as we work through these 3 pages, we try direct substitution if we can. If it works, great, just do it, right? And that's A through D. All of those were all great. And we'll do D. D's obviously the messier one with the fraction and the tangent and all that stuff. I'm going to use the unit circle to help me with tangent of 5 pi over 3. And I'll do that one with you. But like once you get to E, don't plug in -2 on paper. Plug it in up here, right here, and see what works. Right? See if you can do it. And realizing that if you actually directly substitute, you're going to divide by 0, and that's no good. But what kind of divide by 0? Is it 0 over 0, or is it like 5 over 0? Right? Because really big difference between plugging in a number and getting 0 over 0. What are we expecting visually? 0 over 0. And if we see a hole, is the limit going to exist? Yeah, right, because we're going to approach that hole from both sides. When we imagine a hole in a graph somewhere, we approach that hole, the limit should still exist. And so if you look at something like E, and you plug in something like -2, 4 plus 2 minus 6 up top, yeah, 6 minus 6, 0. And so I feel really good about E existing. There's probably going to be a limit there. I'll just do a little factoring to get me there. But look at F. Plug in 3. Not on paper, but just in your mind. That's 8 over 0. That's not a hole. What is it instead? That's the only other option. It's a hole or it's a vertical asymptote. Those are my only 2 choices. And so if that's all I have to deal with, a hole where the limit's going to exist versus an asymptote where the limit doesn't. Right? And having those kind of thoughts running through your mind is really going to help us. If you look at all these functions, rational, 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 rational. Those are the only things we have to worry about, right? Holes and asymptotes. So I want to give you some time to work. I'm going to talk through some of these as we go to help you out. But by the end of today, I would love to have all of them done. Okay, so like by midnight tonight, and we're going to work through almost all of them together. And we'll just kind of go from there. Okay? The other thing I have to do is I have to make a seating chart. So I'm going to take a picture that's only going to stay on my phone until I make the seating chart and away it goes. So if you don't want to be on my phone, then don't look. If you want to just stare at me like a weirdo, awesome. If you want to throw up some deuces, that's cool too. Sweet, there you go. This way I know where you guys are sitting, because these are your seats until you choose otherwise. And if you're like, no, I don't like my seat, I'm going to move to an open one. Awesome. Just tell me so I can update my seating chart. But if you're going to swap and make a deal with the devil, then go for it. Just let me know that you're going to make that swap. So like if I'm out sick, like my sub, like has a seating chart that she or he can go off. Or if, heaven forbid, somebody has to be quarantined, then we're only sectioning off a portion of the class. Like, just to pick an example, like if Aiden has to be quarantined because he was around somebody else, then maybe Brady is safe from also being quarantined because she was smart and she sat as far away from him as well. Cool. All right, so I'm going to put up my work for D just so you can see that. Does anybody else need to, like we did A, B, and C yesterday. Do you need to see those again? Are we good? Okay. So I'm going to talk a little bit, but you can work. You don't have to listen to me while I do this, as easy as that might be. But knock some of these out, right? Hopefully you start to kind of get the habit of, okay, I'm going to see if I can plug it in. Yay, I can plug it in. Or, man, I can't because I'm going to divide by 0. And then I just try some algebraic, switching stuff around to see what works. Okay, but with D, I can plug in 5 pi over 3. It's just going to be a little gross because I have to do the tangent of that. So, away we go. Okay, if you want to try this stuff on your own, go for it. Okay, if you want to like put music in one of your ears and because you work better that way, go for it. I'm okay. Like today's a work day, so I don't mind. I know for me, I always work better with some kind of sound. So, but I'm also going to talk through this as we go. Cool. Here we go. All right, I can plug in this number right away, so the limit notation disappears, and in goes 5 pi over 3. Anywhere there's an alpha, 5 pi over 3 squared. Now, yuck, tangent of 5 pi over 3. This is where I would have taken out my trig cheat sheet, and I have looked at 5 pi over 3 and found that that location is right here. Tangent of that is going to be y over x, because that's what tangent is, right? Sine over cosine. So I have to do that. I have to take negative radical 3 over 2 and divide it by 1/2. That's tangent of 5 pi over 3. It's y over x at that alpha. This is the kind of tangent I love because I can divide away those denominators because we're both dividing by 2. And there's my resulting fraction, negative radical 3 over 1, which is negative radical 3. The issue with that is if you just typed it into your calculator, you're going to get that decimal. And if you don't recognize that 1.73 blah, 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 blah is square root of 3, or whatever it is, I don't even know, 1.73, I think, something like that. Then you have to like back up and do that anyway. If the answer was 1 or 1/2 or 0 or something like that, naturally from whatever y over x would have gotten you somewhere else on the unit circle, then yay, my calculator does all the work for me. But if you get some irrational answer, you kind of have to back up and do that whole thing yourself. Okay, so there's my numerator. Here's my denominator. A fraction squared. Every piece gets squared. 5 squared, pi squared, 3 squared. And you see, I dropped the limit. I don't say the limit as alpha goes to 5/3. I plugged it in. And the moment that number goes in is the moment the limit notation goes away. Now I simplify. A number over a fraction, keep, change, flip, right? Multiply by the reciprocal, which means that this number will be multiplied through that one. Because what's really happening is you have negative radical 3 over 1 times the reciprocal, right? So the denominator gets multiplied through the top. So negative 9 radical 3 over 25 pi squared blah. That is it. And that is gross. But it's perfect. Okay. And so those first 4 were all direct substitution. And that's nice. We love when that happens. But you get to something like e, and it's just not going to work because we'd be dividing by 0. And so whether or not you even check the numerator, whether or not you're going to get 0 or you're going to get something else besides 0, that's up to you. It is going to give you, like, you do a little bit of like thinking ahead of time, and you might save yourself a whole bunch of work. Because if you see it's 0 over 0 versus 9 over 0 or whatever, like 0 over 0, oh, cool, the limit's probably going to exist. Let me do it. Let me actually factor and divide and go through the whole algebra. But if you get 5 over 0, it's not a one-sided limit. It's just x approaching -2. It does not exist right away, right? Anything over 0 that isn't 0 over 0 is a vertical asymptote, and that limit does not exist. So I like to think ahead and see what I get. I like to plug in -2 up top, plug in -2 on bottom, and see what the result's going to be. In this case, it is 0 over 0, so I feel really good about being able to find that limit algebraically, analytically, by reorganizing the function. And we saw the 2 ways we're going to do that: factoring and rationalize. This is a factoring one, but I can't plug in -2 yet, which means I have to bring the limit notation with me as I go. Factor the top. They're quadratic. 2 numbers that add to -1 multiply to -6. Denominator, it just has a GCF. But the limit notation is still there. Need it, because it's now -2 has not gone in yet. And my hope is that I can divide away the problem. And where's the problem? Right here. Plugging in -2 into that factor was the issue. Well, yay, I have an x plus 2 up top and on bottom, so I can divide away the problem. That's why we hope to call it a removable discontinuity, so I can remove the issue. Now, I like to take my time, and I usually write like the results from simplifying. Just maybe it's a little more than I need to do, but I hang on to this limit just for like one more step, and I just write the simpler version of whatever the fraction is. I probably could like skip that red step and just drop in -2 into what's left. That's fine. If you want to work a little bit faster, I'm okay with that. I think that choice is up to you. Cool. -2 minus 3 over 2. Limitation's gone because the -2 went in. And it just goes in wherever there's an x. Take as much or as little time to do your arithmetic as you want. -5 over 2. Now I'm going to work through all of these problems on my own copy of this handout, and I will upload that to Canvas tomorrow after the homework is due. So you can go back and you can check, because I'm not going to work through all of them, but you'll probably want to see them all worked out so you can see how you're doing. And I'm hoping tomorrow is just like another day of practice, more review, kind of building towards the end of this week. We're done with the first half of chapter 1 already. Limits, graphically from a table. Table is at least important, and then analytically, but it takes practice. So I want to give you some time to do that. So we'll definitely review more tomorrow, probably more on Thursday too, rather than taking a quiz on Thursday. So we'll have like a first half of chapter 1 quiz, and I would rather just give you more time to do it than less. Like I would rather say, okay, like we'll review tomorrow and Thursday, and then because you'll see that I want to get you used to AP style questions. Even if you are a senior, I just want to get you used to that style. And so you'll get something from me. Cohort A, you'll probably get this from me tomorrow. Cohort, you guys in front of me, cohort B, you'll get this from me on Thursday. Like practice quizzes. So you know exactly the style question, because like some are multiple choice, some are select like all of the right answers, like tell me which ones are true, and here's A, B, and C, and it's like option 1, A is true only. Option 2, like A and B are true. Option C, like 1 and 3, you know, so like different combinations of things. So I want to show you what that looks like. So I'll be making some copies of some practice quizzes that are like this handout ends on page 40. You'll actually see that page 40 are the answers to your first practice quiz. So I'll just have like another stack it's like 10 pages or so with 2 practice quizzes, just to see the kinds of questions. And I'll let you know which ones to do and which ones not to do, because there are some on there that we don't have to worry about. Is there anything in F that we can simplify? So can we divide away the problem of plugging in 3? So it's not a removable problem, which means it's a non-removable discontinuity. Because look what happens when we plug in 3. Sorry, 3 plus 5. All right. 3 plus 3. 3 minus 3. What's happening there? Visually, what are we expecting to see if we graphed it? So what kind of limit do we have? Do we have a hole? Like, can I keep pointing to something that's not there anymore. Do we have that? No, right? We have like this. And I don't know what it looks like. I don't know if it looks like that, or if they're both going up or both going down. But does that limit exist? Done. And so I tried factoring. Didn't work, but I tried it, right? Never a bad idea. You have to know if you can realize that. Yeah, question. Do we have to show, like, do you have to show that blue step? If you realize that your factoring is not going to get you anywhere, I don't think so. No. I think so, yeah. I would like to see at least one of, like, that first red step, and probably the second red step as well. Like, you plugged it in, you simplified it, you got a certain kind of undefined number. Even though we could do that in our heads, potentially, because it's a pretty simple rational function, we want to show some of that thought process. I think that would be good. So yeah, I would show what's in red, and of course we need that D and E at the end. Ooh, gee, difference of cubes. Ooh, let's remember some things. The acronym SOAP to help us with the signs, but those are just the signs. A cubed plus or minus, because it works for sum or difference. B cubed. Does anybody remember? Oh man, yeah. Well, yeah, because that one's minus. Yeah, so same, opposite, always positive. Those are our signs. So if it's plus or minus, then it's plus or minus. If it's plus or minus, then it's minus plus, and then a plus. Oh, I'll help you. Don't. It's okay. A, B, A squared, A, B, B squared. Yeah. That is the sum and difference of perfect cubes. So this is like 2x being cubed, and this is 3 being cubed with subtraction between. Now I can't plug in 3/2 because I would get 0 over 0. So the limit exists, but I just can't do it yet. Two sets of parentheses, a binomial and a trinomial. Probably need some space.
Mr. Rosenblum?
Yeah, question at home. What's up?
Can you just adjust the camera again back to the screen? Because like some of it's cut off.
Oh, thank you.
Thank you.
You're welcome, thank you. So denominator can't do anything with, it's just 2x minus 3. And I'm just hoping that I can find that factor somewhere. And look, okay, so same, opposite, always positive. First term 2x, second term 3. And then the first term squared, so 4x squared. And then multiply them together, 6x. And then square the last one, 9. Yay, 2x minus 3, 2x minus 3. Again, I like to write the simplest version before the number goes in. I just think it looks really nice. I still need the parentheses though, because it's a polynomial. If I didn't have the parentheses around that quadratic, we would be reading it as just the limit of the 4x squared part, not the rest. But I think we're good now to just drop in 3 halves. As soon as the number goes in, away goes the limit. Do as little or as much arithmetic right there as you want. Let's see, 9, 4, 9, 27. So a couple nice versions of factoring that works, factoring that doesn't, right, with between f and g. Hey, sum and difference of cubes making its way back in there. I mean, how much does it show up? 1 in these, what, 15 problems, right? That's about as often as you're going to see it, but it does come up. So good to recap that. In a second, I'll do h. If you want to get ahead of me, or if you're already ahead of me, great. Notice how much bigger the box is for h and for I. That's not a coincidence. They're going to try to give us a heads up as to how much work we're going to have to show by creating a space, bigger or smaller, to do that. So there you go. I'm going to do h here in a second. Plug in. Let me do something real quick though. Ignore my face. All right, I'm going to do h in case you're interested. In your mind, plug in -2. 0 over 0. All right, square root of 1 minus 1, okay, 0. -2 plus 2, 0. Okay, so the limit probably exists. There's a hole there, so I feel really good about it. But I can't factor. It's not factorable. But we can rationalize. And the only way that rationalizing is going to work is to multiply through by the conjugate of the spot where there's a square root, changing just the sign in between. So +1 instead of -1. But it's not like the square root of 2x minus 5. That doesn't change. Square root of 2x plus 5 plus 1. Top and bottom. And we'll do the same thing for I. It'll just be 1 plus instead of 1 minus. I is just a little bit trickier because there's just some more factoring that we do after the fact there. H works out really nicely where the factoring is pretty simple. I is just a little bit more factoring. So I'll leave that one up to you. Little hint for I, factor out the negative when you get there. But holding on to this limit notation for a long, long time while I get things simplified. Now, I don't know if you remember my advice from yesterday, but wherever the square root was from the beginning, multiply that out. That's why I multiplied by the conjugate. And so up top, I'm going to distribute, which means I'm not going to distribute on the bottom. And here's why. This is the problem. The factor of x plus 2, right? That's what's holding me back from just dropping in the number. So my hope is that I can divide it away eventually. I want to make that go away. If I have a removable discontinuity, let's remove the problem. Right? That's what I want to do. And by choosing the conjugate, I know that things are going to cancel very nicely. The square root times itself is just 2x plus 5. That's 5. But my next two terms in my distribution are always going to cancel. 1 times the square root of 2x plus 5 and -1, right? Those are just opposites. So I don't even bother. Why drive yourself crazy writing stuff down that you know is going to cancel anyway? That's why we picked the conjugate. So those two in between are going to divide away, or add to 0, I should say, cancel out. And then -1 times 1. All right, I am distributing this times that. Pick the conjugate, and things will always work out nicely for you. Again, bottom, I just leave it. Leave it factored. Parentheses, x plus 2. Parentheses, square root 2x plus 5. Plus 1. Now, for very little progress in this step, I'm just going to do the plus 5 minus 1 on top. Not a whole lot I can do just yet. It's going to be a little frustrating to not make too much progress from one step to the other, but that's okay. We've got to take our time to make sure we're doing it right. That's an equal sign. Any thoughts? No. I don't have a common factor, clearly, just yet. Can we find one? I got to get that x plus 2 out of there. Wait. There it is. Nice. Perfect. So sometimes after all of that rationalizing and multiplying by the conjugate and simplifying, you still have to factor first before you can simplify away. And you're going to see we're going to do that in I a couple times. We'll have some factoring to do. So I'll leave that one up to you to do your best. And if you get stuck, let me know. Let me know. I'm happy to talk through it. But there we go. There's an x plus 2 and an x plus 2. Again, I like to write this step with the simpler version. I think it's safer, smarter, but maybe you can work faster than me. You guys collectively are way smarter than me by myself, that's for sure. So do what works for you. Now I can plug it in. The moment the -2 goes in is the moment the limit disappears. extend that out, +1, and then do as much or as little arithmetic in your head as you'd like. Let's do it. 2/2. Ooh, nice. Bam. Welcome to calculus, where it takes like 10 minutes of work to get an answer of 1. Seriously. It's crazy how often stuff like that happens. You do all this work, and it's like, oh, 0. Okay, cool, thanks. So there you go. That's a good one. Very similar, just a little bit more faster. I'll give you a few to do stuff on your own. Ask questions. I'd love to help. We're going to do J. So if you are stuck on J, skip it for now. And then I believe K, L, and M are all one-sided limits. And so maybe we're approaching a hole. Okay, cool. Or maybe we're approaching an asymptote. All right, then we have something a little bit different. How's that process? Are we cool with how it works out? Even if you're not like super comfortable doing it all yet, do you see why it works? How it works? Okay. It's going to be a practice thing for sure, and that's what tomorrow and Thursday will be. More practice, more practice. That's what calculus is all about, getting some practice days in for sure. Just to get you started, 1 plus. Top and bottom. Don't change the sign underneath the square root, just the one in between. Top and bottom. Just to help you out, I'll work through the top. Limit's still there. Leaving the bottom factored. 1 minus the inside. But you've got, this is a little bit trickier because you have the binomial underneath, and so you have to subtract all of that. Again, limit's still there. Standard form makes it easier to factor. Again, denominator is super complicated. I'm just saving us some time. So keep writing it. One plus 1. Yeah, to distribute that negative. That's why the parentheses are so crucial there. Otherwise, you just have 2x squared. Or negative 2x squared. And then factor. Pull out the negative. You have a leading negative. Always factor out the -2 there instead of the +1, because then you can see what's inside, which will be the difference of squares. Because I know what I'm looking for. And this is so important for you to remember. If you're going towards 1, the problem's right there with x minus 1. So I want to divide that away, which means I have to find that factor somewhere. I plug in 1, 0 over 0. Okay, cool. It's got to be there. Got to have a common factor if I can do that. So I'll let you finish that one. I want to talk about J and K with you if you get a chance in just a minute, so get yourself to a decent stopping point. I know I'm talking through a lot of these problems, but you'll have 2 days more of practice before the quiz. That'll be a little bit more on your own. So let's do J. Let's do J. Let's stop and pause wherever you're at. J is super messy, obviously, with complex fractions like this. But let's think about it first. So 0 in the denominator, so that's no good. So I know I can't just plug it in. But what about the numerator? What are you going to get? All right, well, like 1/2 plus like 1/0, right? So do we get 0/0? No, you get 1/2 plus something undefined over 0, right? So we don't get 0/0, so there's not a whole, but I'm also not getting like 5/0 and knowing that there's an asymptote there. So like which one is it? Because it can only really be one or the other. And maybe us kind of working through this one will kind of lead you towards a better answer, and then we'll actually graph it and see what it looks like. But we have some work to do up top. And that's where all of my work is going to happen. I have to put those fractions on top together. And so I'm not going to touch the x on the bottom for a long, long time. Hoping that eventually I have a common factor of x that I can divide away. If I do, then great. There'll be a hole there and I can find the limit. If I can't, then okay, there's an asymptote there and the limit won't exist because it's a limit, not a one-sided limit. So I'm never going to put infinity or negative infinity here. It's either going to be a number or it's just not going to exist. And so let's do some algebra up top. Actually, let me slide down a little bit just so I can write it a little bit clearer. Let's do some algebra up top to put those fractions together. So again, I'm not going to touch this x down there. All the action is going to happen on top. What do we need to add fractions? So let's make a common denominator. Okay. So x plus 2 is one denominator and x is the other one. No factors in common. So your common denominator is just their product, right? X and x plus 2 being multiplied together. And so that's what I'm going to do. I'm going to make a common denominator by multiplying each fraction by the denominator of the other one. And so the 1 over x plus 2, I'm going to multiply by x over x. And I'm not going to write that out. I'm just going to do it. X over x times x plus 2. I'm going to leave it factored. Leave it factored. Make my life a little bit easier. Right? So I'm multiplying that first fraction, top and bottom, by x. Because that's the denominator of the other one. And then same thing over here. I'm going to multiply top and bottom by the denominator of the other one. But I'm not going to write out that step where I have 1 over x times x plus 2 over x plus 2. We can work a little faster. I can multiply the top by x plus 2. And I want a common denominator. So I'm just going to write it in the same order. X plus 2. Again, only action up top to start because I have 2 fractions that we want to add together. So let's add them. Okay. Let's add them. That's the whole point, right? So limit x going to 0. Let's add them together. So I got this fraction up top. And look at where, like, look at the lengths of my fraction bars going across. The main one in the middle is always the longest one. So if you're dealing with complex fractions, make your middle, like wherever the middle of your fraction is, right here, make that the long one as you go through it. So we know where that middle is. Up top, let's just add them together. Okay, 2x plus 2, x plus 2. Common denominator means nothing changes. X times x plus 2. Stick with the blue. Down here we go. All right, limit is x goes to 0. I got to simplify now. Okay. Flashbacks to 40 minutes ago when I did that whole tangent thing. Right, we had a single number over a fraction. Right, where I took the denominator and moved it up top. Well, this is the other way, right? Fraction over a single term. Maybe this will help. if that helps. Always do it, one fraction over another. Because now it's just multiplied by the reciprocal. Take the first fraction and multiply, so maybe you write it like this instead. The top fraction times the reciprocal of the other one, so that you don't mistakenly cross out those x's even though we want to really, really, really badly, because they're both in the denominator. And so, like, what's really happening? Well, if you have a fraction that only has a single denominator, it actually doesn't get, this gets multiplied through the denominator instead of the other way around when we had a single thing over a fraction. But this is so much easier to see that because now we just multiply straight across. I don't have any common factors to divide away. And so, like, what was my goal from the whole beginning? Get rid of complex fractions. Fractions buried within other fractions are way too complicated. And so my whole point in combining those fractions up top was to get to this point right here. And so I did like x times x, called it x squared, but still kept it fairly factored. All right, 2x plus 2 times 1, okay, 2x plus 2, and then x times x plus 2 times x, okay, common factors, I'll at least put those together and put a little squared up there. Well, now what? Is there anything that we can divide away, make it simpler? Like, do we have the exact same factor on top that we do on bottom? Ugh, nope. Nope. Those are all different.
Rosie, we can't see your screen anymore.
Or hear you.
Did he stop presenting?
I wonder if like maybe his camera died or something. I don't
I think his
know.
Wi-Fi cut out.
Oh, that could be it.
Rip.
How far did you guys get?
I have K, L, and M left.
Yeah, I got to K and then I was like, oh great, now because it's the one direction I have to figure out which direction it's going. And I kind of just was like, we're going to wait for him to get there.
I know I lost you. I'm plugging back in. I'm coming back.
Hi, Brady.
There we go. We're back. Sorry about that. I don't know when I lost you guys. So I will retrace my steps for you.
You just lost us right before you gave us the answer.
Oh, good. Okay, good. I thought so. So are we good with that whole second line?
Yes, I think so.
Right, so we just combine fractions by multiplying by the reciprocal. And saw that, okay, now we plug in 0, we get 2 over 0, right? And that's got to be an asymptote, so we know that that limit does not exist. All right, let's talk K super fast, because we have 2 minutes. I want to do it because K, L, and M get us to the one-sided limits where we could say infinity versus negative infinity, so I want to kind of play around with that. But we have to factor first. Because plug in 2 up top, I'm going to get some positive numbers, a bunch of positive stuff, and on bottom, I'm going to get 0. But because we're going from the right, well, I want to do that. I want to actually go from the right. So let's factor. Now, to show you a faster way to factor quadratics when A is different than 1. Factoring by grouping works. The 2 by 2 square works. I got a faster way. Okay. Here's our diamond, right? 2 numbers that add to 7, multiply to 6. Add to B, multiply to A times C. Right? Slow me down if I'm talking crazy. 6 and 1. Now, if it was just x squared, then it would just be x plus 6 and x plus 1, right? And we'd be done. You can actually start that way. This is obviously not correct because that's not going to multiply back to where we were from the beginning. Hopefully you guys can hear me. I'm trying to talk loudly. Here is the trick. This is amazing. So fast. Take A and divide by that number. So x plus 6, x plus 1, not correct. But look at what happens. Does 6 divide nicely with 3? Okay, then divide it. And don't change a thing. That's one of your factors, guaranteed. But what about 1/3? Does that divide nicely? But is that the simplest version of that fraction? Can you make 1/3 any simpler? It's not 2/6 or 3/9 or 5/10 or anything. It's just 1/3. It's a perfect fraction, but it doesn't divide nicely. So take that denominator and make it your coefficient. That is factoring by grouping happening in the background. It's this super sneaky way of factoring quadratics when A is bigger than 1. And I just learned that last year for the first time in my life. And it is so much faster than all the others. As long as your fractions are simplified, you can just move the denominator in front. Keep the number the same, right? 1 didn't change. Just keep it, and the 3 goes in front. 6 over 3, oh, perfect. Yeah, done. Give me a sec if you've got one. So x plus 2, 3x plus 1, 3x plus 1. Factor x plus 2, x minus 2. Even if you don't write it down now, just watch it happen. Those go away. The limit as x approaches 2. So I still have a problem, right? I didn't divide the issue away because it's not a whole, it's an asymptote. But now we can do this part. Let's go to the right and see what happens. If you remember, we did that with like the 0.9 and the 1.1 yesterday, right? We had that function that we just wanted a one-sided limit at an asymptote. I just want to know what direction. So let's plug in a number over here. Give me a number close to 2, but on the right. 2.1. So 3 times 2.1 plus 1 over 2.1 minus 2. A number went in, so the limit goes away. Now, this is kind of shady, informal kind of thing that we're doing here, but it works out, 7.3 over 0.1. So 73. That's not the limit. It's a very big number. So where are we headed? That's There you go. Thank you. So finish that up today. Now, if you really need tomorrow to do it because you're packed with stuff today, I'm okay. Knock that out like as soon as you can tomorrow. No big deal. And remember that tomorrow is homeroom still Wednesday. So cohort A, you're going to go right to homeroom from here. You guys, cohort B, you'll still log into your homeroom as you normally would spawn. Okay, so check Canvas for timing. I know our class is a little bit earlier than usual. Thanks, everybody. So good to see you. Adios.
Thanks. See ya.
Thank you.
Thank you.
No, the reason why 73 works right now here and here is because this function and this one are identical except for this hole, whatever that is, okay? Because we crossed out the problem.
Yeah.
And so the purpose in us, like if we were going to just -2, like me dividing away the problem and plugging this in, what it does, it takes, you know, we got some function, right? So at 2, we've got an asymptote, and at -2, we've got a hole somewhere, right? And so we've got whatever it looks like, right? Something like that. By dividing away those common factors, this is the only thing that changes.
Okay.
That hole just gets filled in, which is why here at 2.1, 2.1 comma 73, that's a point on both functions, the original one and the simplified version of it. The only difference is that hole just gets filled in.
Okay.
There you go.